Exercise 5, boy, question number 30. Given the polynomial fx, when fx is divided by x plus 2, the remainder is 11. When fx is divided by x plus 3, remainder is 6. So how about when fx is divided by this stuff, the product of x plus 2 and x plus 3, what will be the remainder? So maybe something comes up to your mind that the remainder will be equal to the product of, because we talk about the product of these two. So how about the remainder? Is the remainder equal to 11 times 6, the product of 11 and 6, 66? Okay, thinking, I'll just give you an example. How about this? So when 25 is divided by 2, the remainder is 1. Right? When 25 is divided by 5, the remainder is 0, divisible, right? 25 is divisible by 5. So how about the product? 2 and 5 make 10, right? So 25 divided by 10, what will be the remainder? Is that equal to the product of the remainder above? Absolutely no. This is equal to 25 divided by 10, right? So the remainder should be 5, right? Not 1 times 0. So this is not the way to solve this problem. And then what you should do, think about the remainder. Right? Think about remainder. Now look at this expression. This is the divisor. It is a quadratic expression. Right? This is a linear, right? Power 1, degree 1, but this is degree 2, quadratic. When polynomial is divided by quadratic, right? What should be the remainder, right? Something you should bear in mind. We looking back to the long division algorithm like this. Now this one, let's say function fx, a polynomial, divided by this divisor, and this is what divisor is a quadratic, power 2. And then when to stop this algorithm? That means we cannot stop here because the degree here is 2, also 2, so we continue with calculation. Now the degree is 1, and the degree is 2 here. So this degree is less than the degree of divisor, so we stop the algorithm here. And we regard this one as a remainder. So you see that the power, the degree of the remainder should be less than 2, at most 1, right? So the remainder is not just a number, maybe a polynomial of a certain degree. Now this case is degree 1. Okay, so in order to solve this problem, you should bear in mind, you should set the remainder not just R, but a polynomial of certain degree. In this case, it is quadratic. So the polynomial, the remainder should be a polynomial of degree at most 1. So you may let something like this. That is, the function, the dividend will be equals to x plus 2, x plus 3, and I induce the quotient qx, and add not just R. The remainder should be a polynomial of degree at most 1. So how to set the remainder? You may have the idea. This is a general, so-called general expression for the degree 1 polynomial, ax plus b. So you have two unknowns a and b to be found by using the information given. So what is given in the question? So look at the first statement. This one divided by x plus 2, remainder is 11. So by making use of remainder theorem, that means you convert this expression, this statement, into mathematical language. That is f now divided by this one. So you put x equal to negative 2 back to the original, the dividend fx. The result is the remainder, and the remainder is given 11. So we have this. Another given is when fx is divided by x plus 3, remainder 6. So you put x equal to negative 3 back to the original function, that is dividend, and you will calculate resulting in the remainder 6. So we have generated two equations, and then how to use the above information. You see that when put when we are putting x equal to negative 2, we have 11. And fx is something like that. That means you put x equal to negative 2, it will be equal to 11. So that is, you put x is negative 2 to the equation here. So we have 0 here, right? So we have nothing to do with this term. And then you look at this, ax plus b. Now x is negative 2 plus b equal to 11. Right? And then put x equal to negative 3 to the fx. So when x is negative 3, so this term vanish. So nothing to do with this term, and leaving only a multiplied by negative 3, and then plus b equals to the remainder 6. So from the given two information, you have generate two equations, and you solve two unknowns. Okay, so equation 1 subtract minus equation 2. So we have a equal to 5, and then b equal to, let's say you put 5 back to the original equation, that is equation 1, 11 plus 2a, so we have 21. So the remainder is this one, ax plus b. A is 5, 5x plus b, 21.